Hi, my name is Nathan Chega, and today I'm going to be talking to you today about how weather conditions affect golf ball flight. A little rundown about what I'm going to be talking to you today about. I will start off with question and hypothesis, then I'll give you some background information about my project. I move on to materials and methods. I'll give you results about my data collection, and I'll end off with conclusions and acknowledgments. I want to make it clear that I kept the wind constant, which means I set the wind to 0 miles per hour on the golf distance tracking device called the Swing Caddy. Because think about it, wind is constantly changing speed and direction. For example, you're shooting a basketball on a windy day right at the hoop, the wind will knock it right over. So because of this, I wanted to narrow down just to 3 weather conditions, which are temperature, humidity, and air pressure. So, my question was, when I hit my 7-iron in different types of weather conditions, how will weather conditions affect golf ball flight? And I hypothesized that if I hit a 7-iron 30 times a day on a time scale of 10 different days, then the ball would travel farther than hot, humid air. Because lighter air decreases drag of the golf ball, making the golf ball go a farther distance. And inversely, dry air increases drag on the golf ball, making the golf ball go a shorter distance. So some background information on my project. When it's hot, the air density decreases, which reduces drag on the golf ball, making it go a farther distance. When it's cold, the air density increases drag on the golf ball, making it go a shorter distance. Hotter temperature reduces air's density by causing it to expand. So humid weather reduces density because water vapor is lighter than dry air. So the more water vapor there is, the less dense the air is. And lastly, a drop in air pressure will cause lighter air, while increasing air pressure will cause heavier air. And this correlates to the dimples on the golf ball. Dimples on a golf ball enhance this distance by creating a thin turbulent boundary layer of air that adheres to the ball's surface. This allows the smoothly flowing air to stay in contact with the ball surface for a little longer on the backside of the ball, thereby reducing the size of the wake. This phenomenon is related to aerodynamics and explains why a dimpled ball has half the drag as a smooth ball. Therefore, when air pressure changes, the number of dimples on a golf ball determines the amount of drag on this ball. In the project, I used a golf ball with the average amount of dimples, which is 336. And the golf ball I used is a Callaway Super Soft. And now I move on to methods and results. But before I move on, I'd like to address some of the feedback that I was given at the district science fair. Questions being, why 7-iron? Why 30 swings? And how is my project different from the reference work? My project is different from the reference work because my experiment was conducted by me, unlike the reference work was conducted by robots. Robots hit shots in different types of weather conditions using a weather simulator. This allowed the project to be much more effective and accurate. Although my project may have not been as accurate as the reference work, I was still able to conduct a controlled experiment where I can get the data and results I needed for this data collection. So, why 7-iron? Well, the 7-iron is considered an optimal golf club for fitting purposes because it is the middle iron in a standard set of clubs. Also, it is regularly used during a round of golf. This means the room for air is the least among the clubs and the center of standard deviations throughout the clubs. I chose to perform 30 swings as it was the optimal number to establish a correlation between weather conditions and the average distance for each day. Additionally, it was just enough swings to avoid fatigue in later shots. So for now, what I did each day. I first got myself ready at the driving range, the Southwest Golf Center. I got my 7-iron ready, my golf balls ready, and the swing caddy ready. I wrote down the temperature and humidity using the weather app, and I wrote down the air pressure using a barometer. Next, I took my 30 shots. But remember, over a population of 400 shots taken throughout this experiment, this was the breakdown. I took 40 to 50 shots per day and selected the 30 best shots to represent my data over a time scale of 10 different days throughout the month of November. I calculated the average distance for each day, which helped me create 3 different graphs. First, temperature scatter plot. Temperature had a positive, strong correlation with a goodness of fit of 0.98. And for my feedback from the district science fair, I was told to create a meters graph. And in meters, you can see the same trend with the same goodness of fit. When the temperature was high, the ball traveled at its farthest. And for air pressure, there was little to no correlation for air pressure, the goodness of fit being 0.2, but if you look closely, between 30 and 30.1 Hg, the ball traveled at its farthest. And this is because it is ideal range for golf balls. We call this the sweet spot. Lastly, humidity. Humidity had a negative medium correlation with a goodness of fit of 0.2. But this shocked me a bit, because I expected that when the humidity is high, the distance traveled at its farthest. But it was the inverse of this. When the humidity was low, the distance traveled at its farthest. And this is because temperature and air pressure take the bigger effect, meaning they override the effect that humidity has on the golf ball. And now I'll wrap up with the conclusions and acknowledgements. We can conclude from the temperature scatter plot that when there were hotter temperatures, the ball traveled at its farthest. And when there was air pressure between 30 and 30.1 Hg, which reached inches of mercury, the ball also traveled at its farthest. Therefore, my hypothesis can only be partially supported, because I stated that it had to be hot and humid air for the ball to travel far. But for my data collection, all there needs to be is hotter temperatures and air pressure in the sweet spot. If I were to do another experiment, I would do it on the effects wind has on golf ball flight. I would use an anemometer and wind vanes to measure the speed and direction of the wind. This would help me give a further understanding of how weather conditions affect golf ball flight. I would like to acknowledge Alex. He's an Anderson Scholar that helped me strengthen my research plan and give me tips of what to say during the locals. I'd like to thank my mom and dad for guiding me throughout my project and giving me the love and support that I needed. And lastly, Mrs. Dodger McDonald. She's a science teacher that is the reason that I'm here today. Thank you.